Welcome to video number 4 of this series of maths videos to help you with your maths, improve your maths, level 3, so A-level, FSMQ, anything similar. Looking at various topics and extending or improving your ability in those topics, trying to iron out little mistakes that I've seen my students do. Today we're going to look at the binomial expansion. So a really quite straightforward topic. Always careful when I use the word straightforward, but it's something that we do quite early on an A-level course, and many students encounter through the OCR level 3 FSMQ or some of the additional maths quals that are out there, the additional GCSEs. And it's basically a way of working out what an expansion of two terms to the power of something is, without having to spend ages multiplying out repeated brackets. So most examples give you a result to refer to, so you're not expected to remember it. Here it is. This one is as it appears in the Excel formula sheet, but essentially they're all the same, all very similar. So we've got two terms, a plus b equals a to the power n. This notation here isn't a fraction or a vector, it represents the NCR function, the combination function on the calculator, and the powers of a decrease as you go along, the powers of b increase, and I've got the first few terms there. Now I'm going to use this very quickly to show you something that you'd perhaps see on a C2 exam paper or your OCR level 3 paper, and show you how to avoid these mistakes using a couple of very important mathematical words that have very precise and very useful meanings. So we're going to start off by doing that. And the first very important mathematical word I'm going to use is the word consider. So when you write down consider in an exam paper or any other situation where you're writing down some maths, it's kind of saying I'm not going to look at the answer straight away. I'm going to consider something else and then see what that result is. And what I'd suggest considering is a plus b to the power 3 if I'm answering this question. Rather than considering the numbers and the power, let's just put in the power, see what we get. At this point I'm going to try something new. I'm going to try and do some fancy editing so you can see this result come out a lot quicker rather than watching me do lots of maths, which can become quite boring. So there's my expansion. You might notice this is quite an easy example. However, I've still included brackets around all of the terms. I've still used my calculator as part of good practice to work out these values using the NCR button on the calculator. The next thing I'm going to do is use another important mathematical word, not the same one, not consider. I'm going to use the word let, and I'm going to say let a equal 2, and let b equal minus 3x. Ignoring the b that I almost wrote out as a capital B, what this will do is then hopefully it will make what I considered to be what I'm looking to find. So I'm going to substitute in my values for a and b really carefully and check out this fancy video editing again. Okay, so here's my work, and what I've ended up with is 2 minus 3x to the power of 3, which, by considering something else and letting a and b equal the particular values I wanted, I've ended up with my answer. And I've got 8 minus 36x plus 54x squared minus 27x cubed. So the original question, there's my answer, there it is expanded. Things to watch out for, because it's all about tips to help improve. Watch out for negative numbers when you're putting them to the power 3, 2. Obviously a negative number squared becomes positive. Don't forget the x is squared and the x is cubed. You can't just cube the number and then forget that the cube's there. It still has an impact on the rest of that term. So there's my 4 terms. Now this is something you'll practice, I'm sure, with your teacher. You'll practice in lessons and practice when you're doing exam papers. So these videos aren't about exam paper practice. This is about extensions on that and pushing yourselves as best as you can, whilst also improving your general maths. So to do this, I've got 2 puzzles. I know, crazy. Not just one today. I should keep Josh happy. Here's the top one. I've got an expansion there that I've worked on. It's a plus b to the power n. Not much clues there, but it equals this. I wonder if you can work out what a, b and n are in this particular case. And the second puzzle is a little bit more advanced. It's first of all, it's scary because it's asking you to prove something. And constructing a proof can be a quite tricky thing. I don't mind how you construct your proof with this. I think you could do it just on logical arguments rather than anything too fancy. But here's the question. I've expanded p plus qx to the power n, and once it's expanded, I've expressed that as r plus rx squared, where r is a constant. All these p, q, r, they're all constants, and x just remains the same, it's just x.